Hello everyone, I'm Sion Roberts. Yesterday was my 22nd anniversary in the Royal Air Force, so happy anniversary to me. But I'm leaving in February, I'm on terminal leave at the moment, and I used to work with Ben out in America. So without further ado, what I'm going to be talking about today is the smaller aircraft, a bit similar to the EB that you mentioned, Jane, earlier. Their ranges, their sizes, and their capabilities. I'm also going to be mentioning a bit about the regulation as well, which is obviously very, very important. So I'll give you a quick introduction of who I am, the categories and regulations currently available, some of the capabilities, you've seen some already that Jane mentioned, some more payloads, which are critical to the system, some of the uses today, future uses, and then I'll take any questions at the end. So it's going to take about 20 minutes, and I've got some movie clips in there as well to sort of break the talk up. So I'm, like I said, just coming to the end of 22 years Royal Air Force. I spent my first part of my career on Nimrod MR2 aircraft based up at RAF Kinloss, flying low over the sea, making everyone feel sick in the back. And then, luckily, they said, would you like to go to Vegas, Creech Air Force Base? So I asked my wife, and she didn't even hesitate. She said, yeah, let's go. And up until 3 months ago, I'd spent 6 years in the States, 3 years on operations with the Royal Air Force on 39 Squadron. And then I was lucky enough to spend 3 years on exchange at Holloman Air Force Base, New Mexico, as an instructor embedded with the American Air Force, and that's where I first met Ben. He was one of my students. He was not bad, he was all right, average. So overall I spent 2,000 hours, and whilst I was in America I got into the small unmanned air systems to see how I could migrate that knowledge that I'd learned over into the commercial sector and start making some real money. So the company I founded whilst I was out in America is called Eagle Eye Innovations. We're experienced UAV operators, and we're looking at expanding into commercial services and consulting. We've only been up and running for, well, trading is the word, obviously, for about a month, 2 months. We're doing some consulting work at the moment with the German defense company Rheinmetall. So we talked a little bit about UAVs, UAS systems, but how did they come about? So I'll just give you a quick rundown of how things have evolved over the last 100 years. So during the First World War, they developed an aerial target called the Ruston Proctor, which they slowly developed and started throwing it into Zeppelins, and it worked quite effectively. And then in the 20s, the British Aircraft Establishment built and tested the pilotless Larynx. So they started to develop this aircraft that could fly 100 miles autonomously and then come back. But a big leap in unmanned technology was during the Balkans conflict, when the Americans introduced the Predators for the first time. And everybody got really scared because, like Ben said earlier, they thought they'd get red eyes and take over the world. But that didn't happen. But what did happen was that the technology migrated over, as things do, into the commercial sector, and commercial unmanned systems started to take off, pardon the pun, in quite a big way. Now, in the UK, fortunately for us, the CAA has been really pragmatic and forward-thinking, and they could see this happening. And in 2002, the CAA released the Civilian Aviation Publication 722, and this is the rules and regulations for operating these vehicles commercially in the national airspace. 10 years later, it's been revised a number of occasions, but the last iteration was August 2012. Now, if you juxtapose that with what the Americans are doing, they have no regulation. You cannot operate unmanned systems in the United States commercially. You can't do it unless you have special permissions, and I'll come on to that in a bit. But it's interesting to see how our small country with such limited airspace has been forward-thinking and taken the initiative and put these rules and regulations in place. Then last year, DJI, a manufacturer from China, released the ubiquitous ready-to-fly Phantom. Now, this little bad boy is the ones that you see flying over football grounds with flags that they shouldn't be flying on, people going crazy about them. Because you can go into Maplins, and buy one of these systems for £400, and they're fantastic systems. They've got GPS, they've got an autonomous flight system, like Ben was saying, an operational mission. They're easy to use, they're fun, and the imagery they get is really good. And I know because I bought two myself because I'm a big kid at heart, but they're really, really good systems. So you can see in that 100 years how we've evolved to where we have. So this is the sort of category we have at the moment for unmanned vehicles. It's not going to work on there. Ben mentioned the Reapers. Obviously, his talk was on the Reapers. That fits into the MALE, the medium altitude, long endurance aircraft. What I'm concentrating on today, and what I'm going to be talking about, is everything below that, starting with 20 kilograms or less, and then going up to about 150 kilograms. 90% of the systems you can get now are all below 20 kilograms. In fact, I would probably say 70% are all below 7 kilograms. And the regulations is put in place nationally. There is no international onus to tell the CAA what they can do. They can operate those vehicles. As you get bigger to the 150 above, the European Aviation Safety Authority try to get involved as well. But below that, the CAA set the regulations in place. So what do you currently need today to go and fly one of these commercially? Well, there is no universal license. So there's no PPL or CPL, the commercial pilot's license, for unmanned vehicles. That doesn't mean I can go into Maplins and start flying one around and taking pictures of buildings, etc. What you need from the CAA is a permission for aerial work. It's not a license, and it's not universal. I couldn't go to France with this permission for aerial work and start flying around the Champs-Élysées. But it is specific to the UK. Other national aviation authorities around the world have different types of permissions, so it's not standardized. Hopefully ICAO, which is the international controlling authority in Montreal, are going to make some sort of standardization. But at the moment, every country has its own set of rules with regards to unmanned vehicles. So I was looking at doing a job in Morocco, and I searched the internet and basically just ring up a guy, and he says, okay, you're good to go. So it's simplistic in some countries, really difficult and impossible in the likes of America at the moment. Going back to the United States, I sort of lied a little bit when I said you can't do it. They have given dispensation to certain industries. Of course, Hollywood got the first dispensation because obviously you have to keep making their movies using this. So 6 companies in Hollywood have the permission from the Federal Aviation Authority to fly them. And BP are using it in Alaska to do some pipeline stuff and some research and development, I believe. But other than that, you can't do it in the United States. Their rules and regulations are dropping in December, but then it takes 2 years for them to get all the feedback before they can give the go-ahead. So again, we're quite forward-thinking in the UK at the moment. So we can sort of subdivide these small vehicles into your multi-rotor. So that's the omnipresent, ubiquitous Phantom. And then you can move into the fixed-wing aircraft, which similar to the Reaper, like Ben mentioned, but they're a lot smaller. And you can actually launch them by throwing them up or on a catapult or, in some cases, bungees. Now, there's a whole litany of them, by the way. If I was to sit here and mention them, we'd be here all day. And more are coming on the market every day as people start to get into this industry. But with the multi-rotors, like I mentioned with regards to the Phantom, they're very easy to operate. My daughter's 7, and once we were in New Mexico, she was flying it happily over White Sands missile, not the missile range itself, but the national park next to it, and they're incredibly affordable. They can carry a multitude of payloads. I know you spoke about tetracams, multispectral cameras, Jane, and the like, and SAR and everything. And they're great because you can dwell for a long time in one area and just take your hands off, and the GPS will just keep it where it is. And that's why you've got companies like Sky Futures and Cyberhawk who are using that sort of technology for flare stack inspections in the North Sea and beyond. There are lots of different models on the market at the moment, and I'll show you a quick video in a minute just to highlight how technology has evolved over the last 10 years at least. Disadvantages with these ones, though, they have a limited range. So, and I don't mean that they can't go a long distance, they can, but as soon as you get them to about 200 meters out, it looks like a little dot, and it's very difficult to control. I've taken mine out to about 500 meters, and I nearly had a panic attack. But it's not like the EB that you saw that you can put on that lovely racetrack sort of pattern. You are limited in that respect. The fixed wing, the advantages are, like I just said, that they have a longer range. They have a simpler flight system. They only have one engine for a start. They only have one motor on them on the majority, and they can carry the bigger payloads. So when we talk of modern lidars and modern synthetic aperture radars, you really want to start thinking about fixed wing. Disadvantages, yeah, in some cases they're slightly more expensive, and they have that extra launch system, so it might require extra bits of kit to fling them up in the air. Some have to take off on runways as well. And shorter dwell times, and what I mean by that is you can't hover over an area for a set time. It's going to whiz by at about 40 to 50 knots, depending on how fast it can go. So payloads then. Without a working payload, that UAV may just well sit on the ground, because that's what it's all about, gathering that data. And I've subdivided the sort of payloads into two areas, cameras and other sensors. So when I talk about cameras, obviously your standard DSLR, your GoPros, your Electro optical infrared cameras, your multispectral cameras, like the Tetracam, and then your mapping sort of cameras and software. Then on your other sensors, we can talk about radars, the synthetic aperture radar being the primary radar, the lidars, electronic support measures. I don't think really for commercial purposes you're going to be sucking up other people's radars, but it is a possibility for electronic intelligence. And then data gathering devices. And what I mean by data gathering devices is you could send a UAV to a remote sensor in the ground and pick up that data and get rid of the use of satellite communications and cables, etc. So you can use it for there's other sensors other than cameras. So the DSLR and GoPro, great footage from the gimbal platforms. They're cheap, they're easy to use. The disadvantage is that really the IR capability is a little bit heavier for these sort of systems, and they have a limited range. You can't go into the whites of their eyes on the ground, zoom sort of factor that you can with the electro-optic cameras. So here's a little video of the latest DJI model that was released last week, just to highlight the technology and where it's come from. So if you want to impress a date, just go and buy a drone, fly over a vineyard. Well, it works every time, believe me. So you can see there that that's coming out in December. It's relatively cheap at £2,000, and you can go into your local Maplins and buy it. I mean, you can see where the technology has come on. So going back to payloads, the electro-optical IR camera. This is the primary sensor that we used on the Reaper that Ben was mentioning. Mainly composed of electro-optical and infrared systems. They vary in size, shape, and expense. The important thing is the prices are coming down dramatically. The pod that you saw on the Reaper is the most expensive part of the aircraft. But you can buy these now for about £10,000, which compared to I'm not going to tell you how much the Reaper one costs, but it's considerably a lot cheaper than that one. And most of them are coming out in HD as well. So I've got another little movie that is going to demonstrate the capabilities of the EOIR camera. No music on this one, though. It's a bit boring. It's military. So this is the sort of imagery we used to get on a Reaper at 20,000 feet with a standoff range of about 5 miles. And obviously the lower you go with the commercial vehicles, the better the imagery. This is all open source stuff, by the way, so I don't get into trouble. And it's not from a Reaper. I think it's from a Westcam MX-20. But you can see there he's been shooting his 50 caliber machine gun. It's glowing, and that's just the heat that's coming off the barrel. So they're incredible bits of kit, and they're becoming more affordable, more lighter, so we can put those payloads onto the smaller aircraft. Other sensors, Jane alluded to the Lidar earlier, and that's becoming more accessible as well in this technology. It's becoming smaller and cheaper, and the results are fantastic. The other sensor you see on the right-hand side there is a synthetic aperture radar, and that was from about 2 years ago. I was at a conference in DC, and there was a company there making synthetic aperture radar that you could fit quite, comfortably in the palm of your hand, getting that 1-inch resolution and all-weather capability. It's incredible. So a bit about LiDAR, remote sensing technology that measures distance by illuminating the target with a laser. So a bit like the principles of radar. And you can see there on the right-hand side everything that it's being used for at the moment. So a lot of you are probably well aware of its capabilities. But for those who are not aware, I have a nice little video for you. And this is actually one fitted on a small unmanned aircraft, so you can see firsthand the imagery it can get. So you can see it's the great thing about Lidar is you can manipulate that image when you're not actually taking it from that perspective, which blew me away when I first saw it. It was the Lidar image was in front of me, the Lidar sensor, but the image it was painting was of me looking at it, which blew my mind. So it's an incredible sensor. The other sensor that's now widely used on smaller vehicles is the synthetic aperture radar. And as you can see, you can, as I said as well, they're getting smaller and smaller. And they can shoot through the cloud, which is fantastic, unlike the Lidar. And how we used to use it in the RAF is, I mean, this coherent change detection, you can use it in all sorts of applications. But we would take one image at a specific space and point in the air, and then 8 hours later we would take a revisit shot of that, and by overlaying those images you could then see if there's been any movement on the ground. Now this movement that we could detect wasn't even visible to the human eye. It was to do with the radar phase return bouncing back, but we used it to great effect in Afghanistan with counter IED tactics. So if anybody had put an IED in the road, we could hopefully give the guys on the ground a heads up. So uses today: oil and gas. Cyberhawk, Sky Futures are doing the stack inspections all over the place, and like I mentioned, BP are doing some stuff in Alaska. I went to an agricultural show last week and I took a few aeroplanes down there, and it caused quite a buzz. Farmers want to get into it, using the multispectral cameras that you mentioned earlier, Jane, and getting the NDVI imagery to see if their crops need extra fertilizer, etc. News agencies all over the world are using them. Estate agents, if you look at the expensive houses on Rightmove, they're all from unmanned aerial vehicles. Structural inspections, so if you want your warehouse looking at, or Lincoln Cathedral, I know they're using them around Lincoln Cathedral. And I went and had dinner with the British Geological Survey about 2 weeks ago, and we were just chatting, and then they brought out these 3 big unmanned vehicles that they're using to measure various things. So I don't think the question is what we can do with them. I think what can't we do with the unmanned vehicles. But one application I won't be using is Tacocopter to order my tacos. I think I'll leave that one as a concept. So in summary, UAV technology and their uses are growing at an exponential rate. Time magazine incidentally said a year ago that they foresee UAV technology being the second biggest technological breakthrough in the next decade, next to 3D printing. There's a lot of different UAVs, and more are coming on the market all the time. We talked about who's using them. The payloads are just whatever you can strap to it, you're good to go. And my company, Eagle Eye Innovations, we're going to be on the leading edge of commercial UAV services in the next few years, with any luck. So thanks for listening to me, and I'll take any questions if you have them, please.
Thank you. My name's Glenn Hauer. I'm with Innova Geophysical. I have serious concerns about this, mainly because we're going to have possibly a lot of unlicensed pilots flying these things all over the place. That's a big concern from a security standpoint, flying in civilian airspace, for example. So how do you view this in terms of the future?
It's a very, very good point. I've been doing a lot of consultancy, and one of the companies I work with is a security company. And chatting to the guy who owns it, he said the next big threat he sees is coming from the air. He was telling me about weddings that get intercepted by drones, drones, I'm using the terminology again, by vehicles taking pictures and spoiling those Hello and OK magazines. But that's small fry compared to strapping something more volatile to it and putting it in a populated area. So there are things getting developed now, and it's purely embryonic to sort of counter those UAS systems. With regards to unlicensed pilots, unfortunately, education is going to have to be the the big one there. I'm developing a course with Ryan Mattel at the moment to help train pilots and get them that permission for aerial work so that they know all the implications and they can go out there and operate legally. But if you look at America, when I was out there, not a day went by when you would open the newspaper or look on the internet and there would be some sort of drone incursion, whether that be at an airport or what have you. And the problem is you can just go into Maplins, into any shop, pick one up, and you can fly it without any training. So the OEMs, the manufacturers, really need to put better guidelines in place to stop the illegal operators. But it is an issue, and it has been recognised. Yeah.
It sounds like you've got about as much chance of doing that as you have stopping people cycling around Oxford. And
Yeah, it's
being
true.
similarly irresponsible. Anybody else? Ian, please.
Thanks. Ian again. There was something in the British press about 3 or 4 weeks ago about some surveillance of all the French nuclear power stations.
Mhm.
I saw it also in the French press. Any comments on that?
That was a group of guys with the ubiquitous DJI Phantom who'd bought them and then flew them over these power stations illegally. Now, in the air navigation order, certainly in the UK, it categorically states that you're not to go near these areas. And so when people, I mean, I did a course with the CA when I got back from the United States, and it was black and white what you can and cannot do. So those guys were operating illegally, because I imagine the French have the same rules in place. There was an incident about 18 months ago where a guy flew his multi-rotor aircraft in Barrow-in-Furness, the nuclear submarine depot there. He was the first guy to get prosecuted by the CAA, and he got an £8,000 fine and got into a lot of trouble. So the CAA are clamping down on these illegal operators, but you know, if you continue to put them in toy shops, it's going to be very, you know, there's a worry at the moment that after Christmas the sky's going to turn black with UAVs, but I don't think that's going to happen. But there you go.
Okay, Jeff. Yeah.
Jeff Martin, consultant. I was just interested, what powers these UAVs? Is it conventional hydrocarbons or electricity storage batteries, or how do you actually get them up in the air?
90% of them are lithium polymer batteries. So
And the lasting life is about?
well, the technology, the latest one I've got is 25 minutes. Obviously, if you put that into a fixed-wing aircraft with just one motor, you're going to get more bang for your buck with regards to power. But with the multi-rotors, maximum, you're looking at 40 minutes at the moment with the lithium polymer. There's not many unmanned vehicles of that size using conventional petrol gas engine type things because of the price, I think.
Hi, my name is Peter von Kamper from EDMUG. Thanks for your presentation. I'd have a question concerning the use of UAVs for emergency response in oil and gas. For example, if you have a number of gas leak and a number of pockets of gas in a swampy area, do you know of any examples of this being used in that kind of way?
I don't at the moment, with the exception of Cyberhawk and Sky Futures doing their flare stack inspections. But you can strap any sensors to them and do it. It may well be being done at the moment, but I'm not aware of it.
So I can throw a bit on that. Oil spill response, we're looking at UAVs for monitoring oil spills as part of their WACAF project. One of the issues they had was whether there was an intrinsic safety issue with it. So it's still, it's being thought of, but there are still 1 or 2 technical issues that are being raised. But this was 2 or 3 years ago when Kinetic were also looking at civil defence applications for UAVs.
Okay, all done. Sean?
Thank you very much.